in case if you want to organize or if you want to be present a session, so you can contact any one of us, and we are open to having any community coming presenting in our user group. So I will put these links in like on Facebook. Means you can just contact us either by Facebook or Meetup group, or you can email to us as well. So in terms of some of the sessions we have done in past, I will put this short link, so you can just go in the short links and you can browse from the YouTube videos. And these are the most recent one we have done in October and November last. So this month we are dedicating for the completely for the DevOps month, DevOps December. That's called DevOps December, and this is the first DevOps December week. So in which there are two interesting sessions we have. So today our first session is by Mr. Puneet Khanshani. We called him Scott Hanselman of Southeast Asia. He is from Microsoft, and before joining Microsoft, Puneet was Microsoft MVP for 3 years, and he done the contribution in the .NET and Azure community. He was also one of the organizers for them, and he has spoken around 40 plus conferences and forums, and attended 22 plus articles in the international magazines, and I wrote a book on C language and contributed the research on that. And our next session will be by Sam Cogan. It's an introduction for infrastructure as a code, and Sam is Microsoft MVP and architect at Wilson Towers and Watson. Sam is focused in on delivering the applications in cloud and IaaS and PaaS services. Okay. Next is yeah. So related to the sessions, we have done also some of the previous sessions related to DevOps and infrastructure as a code. So if you are interested, you might take a look in that. And apart from that, we will have some upcoming, as I told earlier, because this month is completely dedicated for DevOps December. So there will be some more DevOps related sessions in coming up next week, 9th December and 16th December. So if you like, you can join them. And apart from that, there will be also a data event that's called Apache Data Session Bootcamp, which is happening on 12th of December. So if you are interested and if you are interested in data events, so you can join them. And that there are 8 countries, which is MVPs and speakers are participating in that. So you can join them if you like to. And next will be this is our MVP YouTube channel. So there are some very interesting YouTube videos available. So if you want, you can scan the QR code and you can just go and explore through that. And apart from that, there are some also chart busters. This is slide view is bit. Yeah, there are chart busters videos also available. So you can just go and these sessions we have done in past, so you can just go and take a look at them. And before starting, so it's a bit reminders. So please keep yourself on mute. And if you have any questions, so you can just raise a hand and unmute yourself. And this session is being recorded. So and please spread the you can share if you like the session, so you can share on the social medias like LinkedIn or Facebook or YouTube, wherever you like. So before starting, thanks for joining our session. So now next maybe Puneet will go forward for that. Over to you, Puneet. Puneet, you might maybe you can share your screen and try.
Ashif, you want to wait for 5 minutes or do you want to get started?
Yeah. It's 5 minutes. After that, you can start.
Okay, I'll just share my screen till that time.
Sure.
Hello, Sam here.
Hi. Hi, Sam.
Hiya.
Okay, great.
Puneet, if you show your video, we'll attach your video near the presentation.
Sure, I'll just start off at around 7. Ashif, let me know if you have to stop.
Yeah, Puneet, I think it's 7 p.m., so we can start now.
Okay, cool. All right, welcome everyone on this session on leveling up your DevSecOps maturity. I'm Puneet Ganshani. Asif has given a very good introduction for myself, but for those who joined a bit late, I'm an architect at Microsoft. On the professional side, I've been building and designing cross-platform solutions in different nature of clouds. I've played different roles, starting from being developer, tech lead, product owner, scrum master, and architect. As a hobbyist, I started developing at an age of 5, and I started with different languages, learning from my father, and then got interested more in writing and learning more about C programming. So I wrote a book on C programming, which is still used as reference material back in India. I've authored a few articles in the IT journals, and I've spoken in a few conferences. I was, as what you find, Ashif, Rivut, and Nilesh, I was one of the MVPs back before I joined Microsoft. My new hobby in this COVID times is tennis. So I love playing tennis in the morning and in the evenings whenever I get time. It's not a daily activity, but still something that keeps me busy. But we are not here for tennis, and we are not here to understand Puneet. We are here to understand what is DevSecOps. So we'll keep the agenda very simple. We have few slides, but we'll focus on why DevSecOps, what is DevSecOps, and how do you really implement DevSecOps in your organization. So the first thing when I speak to my customers, developers about security is that what do we view security as? Is security what we call as perimeter security? Like, you lock your house and you assume you're safe. Is that what security is? And if it is so, we've seen that, perimeter security doesn't necessarily always work. We have seen cases where people get into the systems. You have threats from insiders, you have threats from external parties, and depending on the nature of the data that the team needs to acquire access to, the security needs to be tightened. So it's not necessarily just perimeter security. But then that opens up a broader spectrum of thought that how do we really treat security? We start with thinking that there will be breach one day. So we always start thinking that there will be a breach, and that's where we put locks, whether it is through perimeter security or at granular level things that matter us the most. We assume breach and then we try to protect it. But there is a phenomena that we have to start thinking like an attacker does. We cannot just think a bit late into the cycle on bringing security inside our systems. If you look at the top breaches, I'm looking at the Verizon report, the 2020 report, 70% of the breaches were caused by outsiders. 86 were financially motivated, and 43% of the breaches were on web applications, and it has doubled from the last year. Now, more important to me is this 43%, because that's where we as developers, we as system owners can control and can improve our code, our systems, our applications. So let's see, what does this 43% constitute? So again, citing the same report, we see that there are different threats that each systems or different systems have faced. And this is a very broad research on all the breaches that have happened in the last year. But if you look at some of the things, we're talking about three things in particular. We're talking about threats that have stolen credentials, threats that have been due to the misconfigurations, and through malware, where they have captured the application data. So if we as developers have to really build systems, we have to consider that there will be some of these areas where we have to protect our application, have to protect our data, and the APIs that the application exposes. Now, if we go a bit deeper into what the State of DevOps report suggests, now in all my slides, you'll see some of the areas having a QR code there, which is pointing you to some of the links that have illustrated these data points. So if you look at the State of DevOps report, especially what you're seeing is that firms have achieved higher level of security integration are much more likely to be at a higher stage of DevOps evolution. So if you're starting something new, if you're starting fresh into the DevOps journey, you may want to take baby steps. But as you grow along, as you grow mature in the DevOps journey, as you evolve in the DevOps journey, you try to build in security integration within the process itself. But there's another paragraph that says that it is not just the DevOps integration, as in putting it into some DevOps process, but it also means cross-team collaboration, how teams work together to prevent, discover, and remediate security issues. I'm stressing on these things because these are cultural, these are process-related changes, and no tool can automatically fix it unless there is a drive to identify, assess, protect, and then monitor whatever happens on your application. So the natural thing that comes is, how do I get started? How do I really protect? And I'm a fan of chess. And if you see here, the king has few options to move, but the first thing it has to do is to protect itself. So how do we put ourselves into that shoes and protect our system? The first thing, very natural, we have seen some kind of these formats in our source code, in our configuration files. If we have come up from an on-prem world into a cloud world, these may not be something that comes immediately into our minds, but we have seen that people store passwords either on the servers in an on-prem world, and when they move that into a VM, they stay as is into the VMs, or they keep configuration files which have secrets, or they use files like constant.cs into and check them into the source control. So there are three different boundaries here which expose our data, starting from flat file systems, registries, to source control, to configuration files. So all of them are doing this. The other way is links. Now this is an email that I received just today. It's 5 a.m. in Singapore time that I received this email. And if you see, the email raises a security alert. Now whether I trust this email and click on that recover account and that produces a malware, or I trust this email and click it and it doesn't do anything wrong, is up to my intelligence. Thankfully, this email is not an invalid or a phishing or a spam. It was an actual email. So even if I have a strong password, which is the next way, there is a chance of people trying to reach out to your system, whether externally or internally, and trying to leak and get the data from your system. So we need strong credentials, but we also need systems that allow you to notify when such breaches happen, to prevent you with multi-factor authentications. And that's where things like Azure AD or similar kind of systems come into play. And the last thing is around perimeter security. Now, if we correlate perimeter security from what we see in our house, where we use the lock and the key to get into our house, and that's the security, we talk about it into applications in the IT world. Now, these applications could be mobile applications, could be smart devices, small IoT devices running in your house. All of these are perimeters of data that goes out of your applications, out of your systems to external worlds, or are even systems that are running in your house. But a lot of these systems are not really monolith applications. These are systems that rely on APIs. And we talk about APIs, those become the front face of the data that resides behind it. So we may use an application on our phones, and that application may be calling 100 APIs at the backend. But if our phone has a strong authentication mechanism to allow only users authenticated with AAD or similar kind of authentication mechanisms, if the APIs are not protected, your data is still not protected. I'll take an example of the recent breach, one of the breaches that happened. This URL, this came up on one of the white hat sites, had an excellent authentication layer on the mobile, but at the backend, you could see that if you get an access to the API, you could expose a lot of things. So what's important is that how do we secure these APIs to protect our data? So there is an urgent need that we all think security as part of the process. So how do we really level up our defense? So up until now, like this month has been going on, December DevOps, you'll see DevOps as two words that have been used widely in the industry for a couple of years, at least 5-6 years for now. But we talk about development and operations, and what we are seeing there is an addition of security to it to create a DevSecOps. Now, there it could be debated whether security is part of operations, it's not part of operations, blah blah. That's not the context that we are driving in this discussion. The primary discussion here is how do we make code secured, deployment secured, and operations secured so that we have the security embedded across the suite of things that we do. For those of us who follow Agile and Scrum, we see that we use these cycles where we potentially create shippable software every sprint. And then once it gets shipped, after a few sprints, it actually gets into the production, and then you get feature requests, you get a new backlog, and it keeps going. But that is where we think security, we think about it when it is actually getting released. That is where we start thinking, once I start deploying, how does this really work? And the need today is to actually left shift security, which means bring security closer to the development. You start with the minimum standards. You think about information security. If it needs additional members to be part of your Scrum team or your Agile team, bring them along so that it's not an afterthought. It's not the optimal way to implement security, but something that you can bring forward. You can use any tooling but to manage your work, but that security thought process and the changes that are required in the application need to be brought forward into the planning side, into each sprint. So when we talk about left shifting security, we're talking about 4 different things that need to be part of the product backlog, things that you do on a day-to-day basis. The first is to identify issues that could potentially occur in your application. Now reflect back to the few of the slides earlier that I talked about, think like an attacker. So before we go and think like an attacker, we have to start thinking what could be the possible areas where our system could be attacked. That's what is called identification. Then is assessment. Assess the code reviews. Assess the code with reviews. Assess if there are any vulnerabilities. The next action is to protect. Now, it starts with identity, but it doesn't stop at identity. It goes on the ops side as well. What is it that you're deploying? Where is the data being accessed? Within the application, outside of the application, who has access control to your data? And the final step is to monitor. The last thing you want to happen with your application is that it gets breached and you don't even know about it. So it's important that we complete this cycle and add relevant details, relevant user stories into our product backlog so that our teams start thinking security first rather than building the product and then making security as an afterthought. Now, there's a lot of text and verbiage here, but how do we really go around implementing this? So one of the agencies, the same agency that brought us the OWASP top 10 vulnerabilities, have built the security framework, which has 4 levels. Starts with basic understanding, that is where teams, organizations who have limited understanding or limited security processes in their application can start with. But then it very fast goes to level 2, 3, and 4, where you see advanced deployment of security practices at scale. I'll take you through some of these practices and how do you enable them with the tooling. But it's very important that you consider both the process and the culture aspect to make sure that the tooling aids to both of them to accelerate each of these advancements. So a rough primer on level 1. Again, there's a QR code on the right hand side. You can scan it and look at more details. But level 1 touches various things build and deployment, how do you really improve your build and deployment maturity? It talks about culture and organizational maturity. It talks about how do you monitor, how do you log, that is, how do you gather information. And it talks about infrastructure, hardening your virtual network, and goes deeper into how do you test and verify some of the other things as well. So on all these aspects, a maturity count is established. You can try to do this for your applications that you're managing or building and see how mature is your overall process in the terms of security. Now I'll quickly shift to the first thing. Now, if you remember, we talked about identifying the potential issues. So where does the identification start? Now, in a typical project, we start building either the high-level architecture or we start building a design and then come to what the architecture would evolve. So either ways, by certain the initial sprints or if you're following waterfall, by the requirements gathering or design phase, you have a fair bit of understanding of how your application would look like. The first thing to do when you're looking at security as part of your product backlog is to start using that architecture to identify potential threats. Now I'll flip between presentation to a tool which is called threat modeling tool, and I'm using one of the very simple architecture to just keep it simple and make sure that the point that I'm trying to draw here is to identify, not get into the technicalities of what your application looks like. This is a very simple application that has two operating system processes. There is an external interactor that calls the process via HTTPS. There is some data flow by which the data now gets stored into the generic data store. Now this is a tool that you can download. The flow of the information goes from the extractor to the database. And what I'm seeing here is just by putting these things into perspective, I can look at the threats that this system will have from the different protocols. So I have enabled that this is an HTTP protocol, and I can go here and say, show me the related threats. If I'm using HTTP threats, I could end up having an unauthorized access to the OS process. I could also have some issues that the process did get some data from an unauthorized source outside the trust boundary that I've defined. And it's a very simple diagram, but this is where you see all the threats that your system could potentially have. And if there are areas that need to be mitigated, those go straight into your product backlog. So we've seen a way that we can identify threats for our solutions and add them into the product backlog. The next is around securing the practices. We briefly talked about securing code, deployment, and ops. But when we look into the details, it starts with development, securing the code, cleaning up the secrets, then going into creation of the templates that deployed onto Azure or somewhere else, then making sure that the ops is set up for continuous assurance, alerting, and security drifts. So if you're a developer and you're using either Visual Studio Code or Visual Studio, there are different plugins and extensions that you could use to make sure that while you're writing code, you get suggestions on what needs to be improved. Now, these are not a bullet list of all the tools. That's not the purpose. If you're using Visual Studio, any other tool other than Visual Studio, I'm pretty sure there'll be tools for the same purpose. So feel free to choose the tool that fits the best for you. But these are some tools that are my personal favorite and can help find out the problems in the source code. So I'll open up one of the solutions which I had created. Very simple solution. It is an Azure search that indexes the complete websites and then puts the data that has been indexed into a SQL store. Technically, the solution has few components, but we're looking at how do we secure the source code. So this source code exists on GitHub. And while it opens up, what we're going to see is that if I enable the extensions, what kind of potential security issues do these extensions provide? So just let's give it a second. I have some code which is deliberately written in a way that would flash up some errors. So a simple piece of code. We don't need to learn how to write C# if you're not a C# developer, but we are taking some data and storing it into cloud storage accounts. And what we see here is there is a container in which, okay, let me close this. There's a container in which I'm storing the scan data, which is right over here. And then at the bottom, I have this crawl page, which I'm again storing it somewhere. Let me scroll up a little bit. It's a bit slow. It's not something that you want to have it in demo. All right, so you can see some IntelliSense coming up here automatically. If you look at the details of this IntelliSense, it says that the blob is having a public access. That means anonymous clients can also read the container and the blob data. So it tries to find out issues that could potentially arise by the code that you're writing. One of the other things that we have usually use is a word called random, a class random that generates some random numbers. Very frequently used, but we rarely realize that this kind of thing can create vulnerabilities. And what is it? That it's a cryptographically weak random number generator. So we should not be using code like this. Now, similar kind of tools and extensions exist for different languages, which can stop you from writing code that could have potential problems, security problems. So I encourage you to use some kind of toolings like that. Back to slides as my backup. We saw something like this. If there are more suggested fixes that can come up based on what you're using. We all use source control to some extent, whether it is some kind of Git repository or tools like GitHub, Azure DevOps at the onset of it. And all these tools and repositories have mechanisms that prevent us from putting secrets into the code. I'm going back to what we started looking at, how passwords are stored. So we can find out areas where we can improve our security of our application, of our source code, by using the right tool sets rather than relying on disseminating information to your team members and expecting everybody to remember and do it the right way. So one such mechanism is to detect secrets inside the source code. Now, if you have GitHub as an enterprise account, that this is available out of the box. But if there are many tools that allows similar kind of things, even if you are using a public or a private repository, or you're using Git in an on-prem world, the one that I'm showing here is through Git Guardian. I'll flick over to Git Guardian to show you one of the scans that happened recently on a proof of concept that I was working in the morning. So I just accidentally, knowing that I have to deliver the session, and accidentally still copy pasted a URL which had a token in it. Now, technically, I can copy this URL and see the token is invalid. So you may debate with me that it's not a valid account, it's not a valid token, so why do I need to worry? But this is one of the case. It could be possibly also a situation that the tokens are valid. It could be the SAS tokens that you have added into the source code are also live and really the ones that are being deployed. So you want to prevent that kind of thing, and it is not something that you would notice unless you do implement such tools. Now, these tools are not really asking you to click a button and then it will scan. This is automated. So basically, as soon as you put something in, you check in your code, the scan automatically kicks in. It finds out what the potential issues are and then raises them. You can configure alerts and all those kind of things onto these tools, which will give you the right outcomes. If you're using GitHub and you're using the enterprise version of it, you can get these things out of the box. You don't have to go outside into any other tool as well. All right, so this is one such example of continuous improvement detecting during the development lifecycle itself. Now, other thing which comes in GitHub, and you can use this, is around some of the bots that GitHub has provided to all of us. So if you are using GitHub, you can go to a security and analysis tab. You can enable dependency graph, dependent bots, and security updates. And this uses the white source tool that is my favorite, and also uses GitHub's own advisory thing, which identifies vulnerabilities into your source code. When you check in, or when you enable, it scans through all the repositories, however old they may be, to find out the vulnerabilities and raise an issue in GitHub. So let's take an example. I have the source code which I wrote years ago, and it's a .NET source code. And if you look at this, the bot automatically found out that I'm using an older version of Bootstrap. Now, I'm not maintaining this application, but still, the bot identified that I need to upgrade the Bootstrap to the latest version. What it has also done is that it has created a pull request committing the source code and allowing me to review the source code. And once I'm okay with it, commit this back into the tool. Let me see if there's a question. I heard a ping. All right, so you can see that it's not just detecting it, but it's also raising PRs on your behalf, so that you have to do less work, and you're mitigating the issues. And it's not just only for .NET. I have another site which is using Ruby, and if you can see, it has found out that I'm using some open source dependencies which have these vulnerabilities, and it has automatically bumped with 5 different pull requests. So as an individual, I can take a call whether I want to upgrade all of them or one or the other. I can do my testing on each of them and then accept the PR if it goes through. But the key thing is, as we developers tend to use more of the packages and the libraries, whether open source or provided by third parties, it's important to know that we may inherit some vulnerabilities, and we have a technical debt to address them as soon as possible. So this is one such feature that's available in GitHub. I'll be moving between different tools to show you what's available out of the box. If you choose a tool that doesn't have these features, you can still integrate it with the tools that I showed you earlier as extensions. Nilesh is saying that I love this dependent bot feature. Yeah, I think it's one of my favorite ones as well. It's very helpful when you're deploying applications on large scale. So yeah, there are a few of them. Dependency graph, it provides insights into project dependencies, alerts, it sends out the email notifications to the repository owner and the people who have committed that source code that there is a vulnerability, and it is automated pull requests. So you get something out of the box. The next is around secure deployment. So let's switch back to the demo again. Now, we all deploy applications onto Azure. And when we build applications on Azure, we start thinking in how do we deploy it? A lot of people prefer to go on the portal and say, click, 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 add a new service and do some deployment. That's the right way, okay? It allows you to deploy the resources with the configuration. But when you deploy the resources through the portal, you get a limited set of configuration that you can apply. And then you have to go back into some of these things to secure it further. So there are trade-offs in what you can deploy and then secure as immediate goal if you're looking at using the portal. As an example, if I go to the TrailerTread web portal, I have an app service here. And to be able to make sure that it is secured and all those kind of things, I need to go here, look at the configuration, look at the network over here, various areas that we have to configure here. And a lot of times we may miss out one or the other configuration. So how do we make sure that what we're deploying is secured and is repeatable in that nature, from dev to UAT to production environments? That's where we believe in infrastructure as code. So I have this repo. I'll open up the repository. Let me look at the website once, since I'll demo the website in the build. And what we have done here is very simple. We have created an ARM template that deploys what you saw right over here. Few services in this resource group. Very simple: container registry, app service, and app service plan. Very minimal deployments, but that's happening through this ARM template. Now, by default, this ARM template is, you can generate this ARM template from Azure portal over here in the resource deployments, or you can go and write it from scratch and then put it back into the source control. So once you put in the source control, you trigger it to use your deployment. Your deployment looks like this: Azure deployment, ARM output, build an image, push an image, and you're done. This is your typical deployment. What we are introducing here is an extension which works in Azure DevOps. If you're using Jenkins, you can use it as well. If you're using GitHub, I will demonstrate part of it as well. How does that work? So what you can do is you can click on plus and look in Marketplace as a tool that allows you to check your ARM templates for security issues. Typically, developers would just look into these 4 tasks and say, I'm done, it's getting deployed. But if I just go and enable this task, which is doing nothing but taking the ARM template or the path, if you have many ARM templates, just take the path. It will do recursive stuff. Enable it and just save and queue that pool. I'm going to use the Ubuntu one. And let's wait for the run. So this would queue up till the time it queues up. And it's very quick. Good. If you have any questions, you can keep typing on the chat, and I'll keep a look out on any questions that I need to address while the presentation is going on. And you can see this is where the deployment is happening on Azure. So this is the task that will take a bit of time. It's actually seeing if the resource group has all the required services. Probably not valid for this case because most of the resources are already deployed. What I'm more interested about is the template checker, which I think it should reach out in a minute. Now this extension is something that you can enable in your Azure DevOps instance through the marketplace. It's available for you. You can add it to your organization. So if you're not the admin for ADO, you may have to reach out to someone in your organization who owns the ADO for this marketplace plugin to be available. It's from Microsoft DevLabs. So you can get it into your environment and then start analyzing. There's a lot of GitHub documentation on this toolkit as well, which you can also take a look about. It's taking a bit more time than usual, but what we can do is we can see how the same thing can be configured in GitHub in the meantime. So if you're using GitHub, you can also do the same kind of thing, but you'll have to write a bit of code. So I'll expose this repository to you at the end. Then you can see how I've written just a native PowerShell script, just 2 lines over here that can do the job for you. It's installing the module and checking the ARM template status. So once you do that, you can go back into your build. You can trigger a GitHub action. And what you can see here is that when the script ran, it analyzed certain things, and it found out that I'm not using the latest version of Azure Kubernetes on one particular repository. This particular repository, I have totally 4 issues, out of which and they are failed. I can see more of these into the scanned file as well. Some of the issues that my pipeline or my ARM template has, and the same kind of thing you'll get over here as well. If you see, the difference here is that it is also okay. It will also break the build if there are failures into the pipeline. So you can fail that build if you want in your GitHub Actions also, or you can continue your build. It's up to you, but you can do the similar kind of features in both Azure DevOps, GitHub, or you can do it in other version controls or the pipeline tools that you use. We also talked about securing your perimeter multiple times. So starts with securing your source code. Toolings that you use allow you to make sure that you have conditional access. Sometimes if you want to restrict it by IP, look at how you can restrict your IP addresses in which your code should be accessed. That's one area of securing your perimeter. And the other area is that if once you're deploying your application onto Azure, securing your perimeter also means how do you secure your subscription, resource group, and resources. It could be through the toolings that we just talked about. It could be also through the right RBAC, NSGs, and different kind of resources. So if you're looking at virtual networks, you have to look at NSGs. If you're looking at areas that are concerning, let's say, the key vault, who has the access to the key vault from security perspective, from we're looking at the keys to looking at the values in the keys and the like. Now, let's look into one other thing, into the pipeline features. I have deployed this application here, and this application can be viewed as well. But what's important is that do I have the right set of certificates? Do I have the right set of security baked into the process, so that this application is accessed only by the set of people I need. Now, by default, you'll get an HTTPS thing, but if you're looking at custom domains, it's best to go into the Azure DevOps, look at the custom domains, and apply your SSL certificates. Very, very important. If you're looking at ARM templates and deploying applications on Azure, make sure that you use HTTPS only. So these are some of the things where people can get routed from HTTP to HTTPS if you do this. So the website is still accessible, but you see this is not secured. So any authentication, any logging, anything that happens on this website is in an authenticated source. So you will get these kind of problems if you're accessing it this way. And the last thing on the ops side. Now, we have done this in the pipeline, but before the code gets checked in, you can do it on your source code locally into the ARM templates, or as an operations guy, what you could do is probably run this same kind of steps manually. So let's open up PowerShell. And let me get a copy of my subscription key. Give me a second. Right, it's not allowing me to copy here, but that's fine. So let's start this get. Subscription status, subscription ID. And I'll just take one of the subscriptions that I have. Let's go back to source groups. One of them, and I'll cover the subscription ID back here. And what it would do is it will start scanning my subscription for issues that my deployment in Azure may have. So it is not related to an application. As an ops guy, we want to see how our deployments are working, how other applications hosted on Azure are working. This may take a bit of time, but hopefully it will complete successfully, and it will show some of the areas in which we need to improve our security. Interesting. It's taking more than usual. Right. Are there any questions that I need to address? Okay. So probably it's the first time running in the last 15-20 minutes. So it's just importing all the AZ modules, and you can see some action happening on the screen. So you can see that it's found out that I'm using more number of admins or owners to the subscription. So basically people can kind of get into my subscription and access some of the things. It also addresses certain things that I have external accounts or central accounts. I have stale accounts on the subscription. I have used some permanent access given at different levels, and it completes the analysis and will export this into a folder. And let's open up this file. If you open up the security report, it will have the listings of the different issues that were found in my subscription. So you can have a look at here, the statuses are there. It has also recommendations on what we need to fix, different kind of things that we need to do either on the portal or on the script to remove the accounts, to fix the issues that we have seen into our code. Now let's flick back to the presentation here. We saw how the manual detection works, but what's the beautiful thing about this is that this manual detection, even if it is manual, can automatically feed to an engine where we can analyze the issues, not just leave these issues in Excel, because people may forget that this is an Excel file, but get them analyzed into a centralized repository. So if you go back to the demo stage, we have a log analytics workspace where we can go inside, and whatever logs we saw from here, right here, can be fed into the log analytics by configuring the same command. If I go to the log analytics and I say get started, I don't need to see anything else. That's fine. Just close. Let's close this. When I go to custom logs, I can see that the logs have appeared here. Okay, let's widen the horizon to 48 hours. Let's see if there was something that's come up. And you can see some of the scans that I did yesterday. It takes a bit of time to reflect over here, but you can see some of the logs that we have that we scanned have come up here. Some issues have come up. I can further query these to say actual verified result is failed, and show me only those that have failed. So I'll get all the issues that I found in my subscription that have failed, and I can further assign them to someone or make sure that make sure that these things are things that I need to fix. There's a question on Sentinel. Yes, Sentinel also takes care of a lot of things. Look at it from configuring these into Sentinel as alerts. Whatever you scan here as is broader in the sense that it identifies a little bit more granular level details also, but then this gets integrated into the Sentinel as well. That's where the key thing is, that these logs do not just stay as Excel sheets. These can be triggered through the pipeline, and they can be fed into the log analytics as well. So in fact, one of the things that I had in this presentation was also around continuous assurance. So you can, while you're seeing this all run manually, you can create run books. So by just using a script. I've already created one. I can show you how it looks like. But what I've done is this resource group has a automation account and a run book, which actually executes these scripts and runs at the frequency that you would want. That means it can continuously scan your subscription, and if there are alerts, if there are issues, it can raise alerts that your different teams can look into. So all these things tie up from a secure code, starting with writing secure code, fixing the problem in the source code, and even before that, finding out potential threats that your application may have. Then going into securing your deployment and making sure that whatever gets deployed is correct, and then handing it over to the ops team as part of your own team that have a mechanism on finding out similar kind of issues as a continuous assurance. So throughout the life cycle, security becomes the primary goal. It's important that we think security first. It's not something that we can think as an afterthought and then target to fix it. We discussed this. This is a centralized monitoring and alerting mechanism. You could use Security Center over there. All these can feed into Security Center as well. And then from there, you can send notifications to different set of people on severities and all those kind of things, to group of people, to individuals as you like, to potentially fix these issues as they come along. With that, I'll open up the forum for any questions. We have some time today. Non-functional requirement. I'm sick. I'm growing. Okay, I'm growing younger day by day. Thanks, Nilesh, for this. Probably it's the camera effect. I would just give it to that. Right, I see Mike and Honghua typing. Any integration with Jenkins? Yes. So if we go back into presentation, or let me flick back to GitHub. So there is no native integration with GitHub for this security thing. But what we have done here, if you look at what I've tried, is just 2 commands. Not a lot to worry about, not a lot to think about. Just 2 commands which you can integrate in any of your pipelines. So let me go back to the workflow, new workflow file. And if you look at it, I'm just running 2 modules here, 2 things. Install AZSK and then get the ARM status. This is getting you the status of your ARM templates. But let's look at it from a different perspective. It's not just the ARM template that you want to scan, right? Once you have, it could be multiple ARM templates, it could be subscription, it could be a resource group. So this command that we just talked about, the one over here, let's go back into the deck. Get subscription request status. Let's go back to the PowerShell score and just write this. Okay, so I can actually write subscription ID here. And then I can also set resource groups. So just like here, I have added a resource group saying star, all the resource groups. You can actually go into one specific resource group that you have already deployed. So you can do all these things in any tooling of your choice. The commands are there as PowerShell scripts. So as far as you can run PowerShell core runs on both Windows and Linux. So you don't have an operating system dependency as well. You can very well integrate this and run it in any toolset. Thanks, Gaurav. All right. If there is nothing else, I'll hand it over to Asif.
Thanks, Puneet. Really nice session and a lot of new things to learn for us. Yeah. Maybe will you share the slides after that? So will be.
Yes, I can share. That's not an issue. Most of this is already in public forum. But yes, the thought process and something is very important that we all bake into our processes and the culture that we run in our companies to make sure DevSecOps is the primary objective.
Yeah. Thanks a lot. Thanks a lot, Navneet. Nice session. Okay, hi guys. So if you have any questions, you can ask. You can unmute yourself and can ask directly. And our next speaker. So we have another very interesting topic, infrastructure as a code by Sam. So yeah, maybe Sam, you can just share your slides. And Sam is Microsoft MVP and a solution architect with Wills Tower and Watson Group, and he's focusing mainly on the cloud apps, Docker containers, and Kubernetes. So yeah, what do you, Sam?
Okay, so hopefully you can see the slides okay?
Yeah, we can.
Okay, so we can get going. Yes, so today I'm going to talk about infrastructure as code, and this is really a sort of an introduction to the concept and look at why we might want to use it, what it's for, what it's going to achieve, and some different tools and different processes you can use to start your journey on infrastructure as code. So if you've been working with infrastructure as code for a while, a lot of this might be a little bit basic, but for those who are sort of coming to the topic fresh or want to learn about the different options available, then hopefully we should cover all of that in this talk. Yeah, so my name's Sam Cogan. I'm a solutions architect for a company called Willis Towers Watson based in the UK, and I'm also an Azure MVP. And I spend a lot of time working with infrastructure as code, both in my day job and when talking to people in the community. It's kind of an area of expertise that I work on, and I've been doing this probably for the last 5-6 years, starting with sort of basic tooling, a bit of PowerShell, those sort of things, but working through things like ARM templates, Terraform, other tools like Pulumi, which we'll talk about as well. And so, I've worked my way through the different levels of infrastructure as code and the problems and things associated with it. So hopefully I can give you some insights today on what that's about. I blog about a lot of different things, but infrastructure as code in particular, so samcogan.com if you're interested in reading any further articles. And I'll put the slides and the code samples from this talk on GitHub as well when we're done. So if you want to grab any of those, you can get them from my GitHub. Okay, so it's the first question if anyone's coming to this is what is infrastructure as code? What actually does it mean? How does it work? And there are various different definitions of infrastructure as code. This one on here is a very generic one, provisioning resources using machine readable definitions rather than iterative configuration tools, or in fact, doing things manually, going through the web portal, or actually sitting down in front of a physical machine and installing things. So infrastructure as code at the highest level is deploying and configuring your infrastructure using programmatic means rather than doing it manually. But that's fairly generic, and that could encompass anything from writing a quick bit of PowerShell all the way up to some of the more complex infrastructure as code tools that we see today. So generally, when we're talking about infrastructure as code in the cloud world, we refer to these sort of components here. And infrastructure as code has been around for a long time, but it's really started to sort of be a factor when we started talking about cloud. Because we're no longer able to sit down in front of physical hardware or even virtual machines that are in our data centers, and actually we're having to work with a cloud provider who provides prescribed ways for deploying those infrastructure. We want to find a way to do that better, but also because we're now working in the cloud world, we want to be able to deploy resources on demand. We want to be able to scale dynamically, and none of that really works if somebody's got to go in and manually go to the portal and create new resources and so on. So in the cloud world, infrastructure as code usually has these sort of attributes. So first up is that it's declarative. And this is where we move away from the PowerShell scripts and the Bash scripts and so on, which are generally more, not declarative, I guess is the word, but they're imperative, they're running through different steps, and you're actually writing the code to tell it how to deploy something. Whereas with more modern infrastructure as code solutions, you are telling it what you want to deploy and letting the tooling decide how to deploy it. So my infrastructure as code files will just say, I'd like a storage account, I'd like a virtual machine, I'd like a network card, and I'd like them configured in this way, but I don't care how you deploy them. That's not my problem. So when I run my code, my infrastructure as code, the platform is going to be translating that into whatever calls it needs to make to the fabric to get things deployed. It's going to handle any errors for me and just return the error message and those sort of things. So it's all about declaring what I want rather than how I want it. Alongside that is the concept of idempotency or repeatable infrastructure. So if I deploy a piece of infrastructure as code once, it's going to deploy certain things. If I run it again, I want it to do the same thing. So if it's deployed 3 virtual machines for me and I run it again and I haven't changed anything and those VMs are actually, or they're there and they're running, then my code shouldn't do anything. It should leave it alone because it's configured the way it is. However, if I go and change some of those things manually and run my code, it should recognize that there's a change and try and revert it back to what it was before. Infrastructure code also looks at the concept of immutable infrastructure, and this isn't a requirement, but it's more of a concept that this allows. So obviously in the past, when we were manually configuring things, we would go in and we would make tweaks and changes over time, and if a server started failing or wasn't working properly, we'd go in and try and fix it. Whereas the concept of immutability is really around, okay, well, this is my server and this is how it looks, and if it breaks, I'm probably just going to destroy it and create it again. And if I need to make changes, I'm not going to make those changes directly on the machine. I'm going to make changes to my code, and I'm going to deploy those and potentially even destroy the existing one and redeploy it for a change. So you can go as far as that and to say, actually, we never change the existing infrastructure. If we need to make a change, we destroy it and we rebuild it. There are different levels of mutability, whether or not you want to implement them or not. Reusability also then comes into this. So if I write an infrastructure as code file that's going to deploy my environment, I can actually reuse that, because if I need a dev and a test and a prod environment and I want them all configured the same, then I can just run that file 3 times and get 3 different environments. If I parameterize it properly, I can make those, I can allow for changing of certain variables, like maybe you need less virtual machines in your dev environment than you do in production. So I can allow for that, but I can make the main bulk of my code reusable, which means that when I deploy those environments, they should be the same. And I shouldn't have inconsistencies between my environments. Most infrastructure as code tools also feature some sort of modularity as well, so that you can write reusable modules that you can then distribute to the people running your code. So you can write a module that defines how you deploy a virtual machine in your company. And that might include obviously deploying the actual virtual machine, but maybe there's some configuration you apply, maybe there's some certain plugins you apply, maybe there's a security settings you change, you turn on Security Center, for example, those sort of things. So you could have a standard way you deploy virtual machines. You could wrap that up in a module in your infrastructure as code solution, and then distribute that to your team. And so whenever they want to actually deploy a virtual machine, they take your module, pass in some parameters, and that's pretty much it. So they don't have to work out all the logic. They know what a virtual machine in your company looks like because they have this module. And then lastly, I already mentioned this a bit, but there tends to be some sort of drift correction. So if I run my infrastructure as code file and somebody's manually made changes, or maybe there's been some changes applied by a different tool, it will see that difference and it will correct those changes and set it back to what I asked for in my infrastructure as code. If you want that to happen, obviously there are some scenarios where you might actually want to be able to make changes from 2 different sources. It's not ideal, but some people do want to do that, so it's usually an optional thing. But this is what modern infrastructure as code solutions will allow you to achieve. And so the question then is, okay, well, that sounds great, but why would I want to do that? What would I achieve by implementing infrastructure code that will be a benefit to me? And so there's a list here. I'm not going to go through every single one, but obviously, there are different things that will make your life easier depending on what you're trying to achieve. The most obvious one is around consistency. If I'm deploying something from code, then every time I deploy that, it should be the same because it's working from this code file. It isn't reliant on somebody coming along and manually configuring it using the portal or using a console or whatever, that might forget to do something or might make different changes and so on. You've got consistency. You've also got speed because you're now deploying from this infrastructure file. You're not having to manually go through and click on all the buttons. You just run this infrastructure deployment, and it takes as long usually as the cloud provider will take to actually deploy the resources. Because the OM infrastructure is now defined in code files, you can actually now share these between your teams, and you can collaboratively work on the infrastructure. So it allows you to have maybe you've got one person who works on the networking piece, another person work on the VM side, and so on. You can collaborate on that. But because they're in files as well, you can also actually have some sort of accountability and change management. You can store those files in Git. You can have an audit log of the changes you've made and who's made them and why. And you can version those, potentially even, now this is code in your Git repo, you can then start doing some of the other things that you might do with code. So you can look at testing, and we'll show some examples of that in a minute. You can look at building pipelines using this because it's just code at the end of the day. So you could take up all those tools. And then documentation becomes a part of this. Because you're writing your code in a file, that can become your documentation. Now, obviously, this is actually written in code, so it might not be all the documentation you need, but you do now have a document that shows what you're trying to achieve, what you're trying to deploy, rather than, again, somebody manually doing it and having no record of what's being done. You've got a document that allows you to see what it is you were trying to achieve. Okay. So one point I just want to make clear before we delve into this further is that there is a difference between infrastructure as code and configuration management as code. So infrastructure as code, in my view, is talking about how do we deploy actual infrastructure resources to our cloud provider. So how do we deploy networks, virtual machines, storage accounts, Kubernetes clusters, whatever, those sort of things. And those are the tools we're going to look at today. There are a whole range of other tools which do more configuration management as code. So things like Puppet, Chef, Ansible, Salt. These are designed for configuring virtual machines at the operating system level once you've deployed them. And that's sort of the next level up. So infrastructure as code is how we get the virtual machine deployed. Configuration as code is how do we actually configure that virtual machine once it's been deployed. And usually there will be a handoff between the two. So the infrastructure as code tool may then kick off the configuration management when it's completed its work. But they are two different tool sets, and we're going to focus on the infrastructure as code piece today. Okay. So there are two buckets of tools that we're going to look at. There are the cloud vendor specific tools. So these are the ones created by cloud vendors to actually deploy the resources into their specific cloud. And then there are some third-party ones we're going to look at. So from the cloud vendor specific ones, we're really looking at the big three clouds. They each have their own. So AWS has got CloudFormation or CDK. Microsoft have got, Azure's got the ARM templates, and GCP has their deployment manager. These are created directly by them. And so these have the benefit of being supported by the cloud vendor, but also usually being the fastest to update when new versions of new things in the cloud platform are introduced, because usually they get released as they release the new tooling. So there's benefits in doing that. Another benefit is potentially, depending on how you look at it, is the statelessness of these. So all three of these tools are stateless. They don't record the state of your infrastructure separately from the cloud provider. Effectively, their state is the cloud, and you'll see why that might be a benefit or a disadvantage. And you see it's in the negative column as well in a minute when we look at the third-party ones. But what this means is that when you run and try and deploy your infrastructure as code against these cloud providers, you are effectively running against directly what's in the cloud provider and comparing it against that. This will make more sense when we talk about the benefit of state with the other providers, but that's something to remember. On the negative side, these toolings obviously are focused on a single cloud. So if you are trying to do some sort of multi-cloud approach, or even you want to deploy to non-cloud resources as well, you can't really use these tools, or you need to use multiple different tools. If you want to deploy to AWS and Azure, you'd need to write some stuff in CloudFormation and some stuff in ARM templates and so on. Most of them are closed source. In fact, all three of them are closed source, so they don't release the source code for these things. So depending on whether you that's a big factor to you, that could be a negative. There isn't really an easy way to commit back to these things or have a look at the source to debug issues. So that can be a problem for some people. So let's have a quick look at what that looks like and how you would build some tooling or some infrastructure with that. Okay, so what we've got here is an ARM template. Let me zoom in slightly. So this is to deploy some resources to Microsoft Azure, and all we're actually doing here is deploying a storage account. It's a fairly simple thing to deploy. So ARM templates are written in JSON. There is some work being done at the minute around a new language called Bicep, which will sit on top of this, but that's in very early preview at the moment, so I won't focus on that. So currently, if you want to use ARM templates, you're going to use this JSON-based language. And you write your code in different sections. So the first section of the file is the fact that you can pass in some parameters. So I mentioned earlier, if you want to parameterize your templates so you can vary different things, then you can do that. So here we're allowing the end user to pass in the name of the storage account they want to create and select the SKU, so the size or the type of the storage account. And so for this one, we're actually providing a default value. So if they don't provide anything, it'll pick standard LRS. And we're restricting the values that they can actually use as well. So those are the two parameters we're allowing the end user to pass in. We've got a variable, which is just a sort of an internal variable. It's not something you can change from the outside, but it allows me to store that here and then reuse it in different parts of the template. And then we've got our actual resources. So when we want to declare the things we want to deploy, we add them into this resource section. And there will be a specific syntax for each type of resource. So this is a storage account, and for that we have to specify a name for the actual storage account. Everything will have a type, so this is the actual type of resource we want to deploy. An API version, which is that value up here. So if you're not familiar with how Azure versions things, there is a sort of date-based version for each instance, for each type of resource, and as they change the resource, they'll add new API versions. And then we can pass in specific properties that we want for that actual resource. So we can add some tags, we can set a location where we want that to be supported. And then these are the storage specific ones. So a storage account requires you to specify a kind, which is the actual sort of SKU of the storage, well not SKU, but the type, and then the SKU, which is the locally redundant, geo-redundant, those sort of things. And so we're passing those in. You can see here that for the kind, I've hard coded that to storage v2, whereas for the SKU name, I've passed that in as a parameter. And so it uses this language, this square bracket, and then properties language, where you can pass in the parameters. I've done the same here with the name. So all that's going to do when I run it is create the storage account for me, and that's pretty much it. Now, when we run it, we need to pass in the parameters. And there are two ways you can do that. You can either pass them in at the command line when you run a deployment, or you can create a parameters file, which is what we've got here, which we sit alongside it, and we can pass the actual values in here. So I'm passing in a name for this storage account. I'm not passing in the SKU value, so that will take the default. And so this is enough now for me to be able to deploy that resource using my infrastructure as code tool. And the way you would generally do this with ARM templates is from the command line. So you would run this PowerShell. There is an Azure CLI command as well. But this is a PowerShell version to run the new AZ resource group deployment, where you basically pass in the resource group you want to deploy to, the template file with the actual template in it, and the parameters. If we run that, that will go off, and that will create those resources for me in Azure. And that'll take a couple of minutes, so I won't sit and watch it, but that's how you deploy an ARM template. It's fairly straightforward to actually deploy it, and you can obviously do this from CLI, from PowerShell, but you can do it from Azure DevOps pipelines or Jenkins or whatever pipelines tool you use. You can build a variety of different tooling to actually run the deployment. But at the end of the day, what it's doing is it's running that template file for you. And you see that's finished, and it's created a storage account for me. Actually, if we pop over to the portal, you should see that has been created. There we go. So that's now been created, and it's ready to use. So that's how ARM templates work. And if you want to look, if you are interested in looking at GCP or AWS, the solutions there are similar. Obviously, the language is a bit different, and the resource types are different, but the concept is pretty similar. So, alternatively, if you don't want to look at the ones native to the cloud providers, there are some third-party tools that can be used to deploy resources into cloud providers. And we're going to look at two of these today, which are Terraform and Pulumi. You've probably heard of Terraform. Pulumi is a relatively new one, but it is quite an interesting concept. And these third-party providers, the big benefits of these is the fact that they can support multiple clouds. And in fact, not just multiple clouds, but other providers as well. Because they're third parties, they obviously want to allow you to use as many different things as you can. So you can use these tools to write deployments that will deploy some stuff to Azure, some stuff to AWS. You can even have it talk to your own on-prem Kubernetes clusters. You can have it talk to a lot of different providers. Most of them have multiple, tens or even hundreds of providers they support. So if you're trying to use a single language to deploy to multiple places, then these are things you could look at. Bear in mind that each provider has its own resources. So a virtual machine that you want to deploy to Azure is different to a virtual machine you want to deploy to AWS. You can't just write a generic virtual machine and have it deployed to either. The language concepts for each will be different, but you can use the same tooling. These providers also have state. So what that means is when you run Terraform or Pulumi, it records what it's deploying to the cloud provider in what's called a state file. So this is a file that's separate to your cloud provider. It's managed by Terraform or Pulumi, and it records everything you do and what gets created by the cloud provider. And the benefit of this sort of thing is that the tool now knows what it's done and what the state of things are. So it allows you to have some extra components, the biggest one being a plan tool. So you can run a plan command, and I'll show you a demo of that in a minute, that will allow you to see what the tool is going to deploy before it deploys it. So what changes it's going to make. So you can actually have a look and say, okay, well, if I run this, it's going to delete this resource and change this one and add this one. So you can get a view of what's going to happen and check that is what you expect it to be before you actually run it, which is a pretty useful tool. On the other side, though, it also means that it knows what it's deployed, so it can destroy it. So when we ran the ARM plan template before and it created that storage account, if I wanted to get rid of that storage account, I'd have to either go into the portal or run some PowerShell or something to actually delete it if I wanted to. And that's okay for one or two resources, but if I had a load of resources, then it could be a bit painful. I can go ahead and delete the resource group they're in, but obviously that assumes everything in that resource group is what I want to delete. Whereas with these two tools, they know what they did. So I can run a Terraform or Pulumi destroy command, and that will go and delete everything I created. And where that's even more useful is where you start looking at creating things that are not just Azure resources. So one of the big benefits I've seen with this is creating Azure AD resources. So a lot of the times when you're deploying an application, you create the infrastructure, you create the web app or the VM or whatever, and quite often you need a service principal from Azure AD to work with that. Now, I don't know about you, but there have been plenty of times where we've created those sort of things manually for an application. The application's got decommissioned and deleted, but nobody ever remembers to go and delete the service principal. And so you get a load of expired service principals sitting in Azure AD. Yeah, they're not doing an awful lot, but they add to the complexity of using your Azure AD. Whereas because these tools support not just Azure resources, but you can create Azure AD resources as well with it, which you can't do with ARM templates, then it will also delete those when you're done with them. So it makes sure to clean up after itself. So that can be quite a big benefit. Finally, both Terraform and Pulumi are open source, so you can go and look at the source code, and you can commit and make changes to it if you want to, and you can see what it's doing. On the negative side, because these are third-party providers, they obviously have to implement the changes that Microsoft makes. So if Microsoft release a new resource or change a new resource or release a new API version, then there potentially can be a bit of a delay between when Microsoft release them, when they're available in ARM templates, for example, and when they actually get integrated into Terraform or Pulumi. Generally, it's not huge. It can take a week or two, depending on how complex it is, but there is the potential for a bit of a delay. Pulumi actually released a new version of their Azure integration that actually pulls the specs directly from Microsoft's API. So the Pulumi one is actually now potentially going to be quicker than the Terraform one to get updates, because all they need to do is rerun a build and get a release out. There's no manual changes they need to make. Whereas Terraform, there is actually, they have to go in and change the code to work with a new resource. The downside of having state is that you've got to manage the state file. So most of all of these tools will create a state file. You have different options of where to store it. So the default, if you just testing it out, you can store the state file locally on your machine. That doesn't really work if you're trying to work then with a team or multiple people. So you can store the state file in, Azure Storage is the one, most common one for Azure. You can store it in an S3 bucket. You can store it in different places, but you do have to store that, and you do have to make sure it's secure and that it's backed up potentially. Because if you lose that state file or it gets corrupted, then effectively, as far as Terraform and Pulumi are concerned, nothing has been deployed. So when you run your deployment again, it will look at the state file, see there's nothing in there, and it will try and deploy the resources again fresh, and obviously probably hit errors because they already exist. So you do need to look after that. And in particular with Terraform, one of the big downsides of that state file is the fact that when you deploy anything and it creates a resource that has a secret, so take a storage account, for example, when you deploy that and it creates an account, it will create a storage account key that will be stored in your state file in plain text. Now, this is a bit of an issue. It's been an open issue on Terraform's GitHub repo for about 5 years now, and it doesn't seem to be getting any closer to getting resolved. So you end up having to look and make sure that state file is locked down. The storage account, for example, has got specific IP restrictions and so on to make sure that's secure. It's less of an issue with Pulumi, because one of the reasons I quite like Pulumi is the fact that you can actually encrypt data inside the state file now using your own managed key. So that's a big benefit of that if you are concerned about the security of those state files. So that is something to think about if you're going to use it. They do have a number of benefits, but you do have to look after them. Another downside obviously is that they're third-party tooling. You won't get support usually directly from Microsoft or Amazon. If there's a problem with them, you will need to go to the third party. Sometimes that will be through community support, through GitHub or through Slack channels and so on. But if you want actually a support contract, then obviously you've got to pay for that, which you potentially already paying for through Azure or Amazon or so on. So that is potentially an additional cost. There's also an additional cost if you want to take on some of the more enterprise features of these tools. So both Terraform and Pulumi have an open source version which will allow you to do most things. But if you want to do some of the things, particularly they have options to allow you to have a web portal to manage your deployments. Some of the policy as code stuff is all part of their enterprise offering, which has an additional cost. So that's something to bear in mind. So let's have a look at how this works and how different it is to an ARM template. So we're going to do the same thing. We're going to deploy a storage account, and we'll start off looking at Terraform. So this is a Terraform file. It's not too different from ARM templates, but this doesn't use JSON. This uses a custom language called HashiCorp configuration language. So you'll notice, there's no semicolons, there's no commas and so on. It's a more simplified version of what you would get in ARM template. So I think personally this is a bit easy to read. And inside this file, we're declaring the same sort of thing. So the first thing we're doing is we're declaring a provider. So we didn't have to do this in ARM templates because when an ARM template deploys Azure resources, that's all it does. Whereas Terraform allows you to deploy different types of resources. Each of those is denoted by a provider. So we're telling this that we want to use the Azure RM provider and giving it a version. And we could have multiple providers in this file. We could add an Azure AD one, we could add a Kubernetes provider, we could deploy to multiple different places if we wanted to. Next, we're creating a resource group. Now, you'll notice in the ARM template, I didn't create the resource group. It was already created. I did that manually through the portal. You can create resource groups in ARM templates, but it's a bit more complicated than what we see here. ARM templates have this concept of scope, where you run, when you deploy your template, you run it at different scopes, or one specific scope. And so there is a resource group scope, which creates things in a resource group. There is a subscription scope, which creates things in a subscription like resource groups. And then there's a management group and a tenant scope as well. So for us to do what we're doing here and create the resource group and then create the actual resources inside it, we have to run our template at the subscription scope to create the resource group, and then run a second template at the resource group scope to deploy the resources. That is achievable. You can actually do it in one go, having one template calling another template, but it's a lot more complex than we see here, where I'm just saying, give me a resource group and then give me a storage account. Now, in terms of the actual resources, you'll find they're very similar to their ARM counterparts. So for a resource group, I'm just giving it a name, and this name here is just a name that I refer to it in my Terraform. It has no bearing on what my resource in Azure is actually called. It's just a reference for Terraform. Sorry, this one is the name. This is the actual type. So when we saw the type in ARM template, it's a similar sort of thing. It's saying I want a resource group, and the Terraform name is example. Then I give it the properties that actually Azure cares about. So this name here is the name of the actual resource group that's going to get created in Azure, and this is the location it's going to get created in. Then I go on to create my storage account, and you'll notice say it's very similar. I'm giving it a name, I'm giving it the tier and the type. You'll notice the names are actually different. So this in the Azure, the ARM template world was SKU, but they are the same sort of things. And then I'm referring, so when we look at the resource group name, I'm actually referring back to this object to get the name. So rather than actually hard coding that name in, it refers to whatever this name was. And that has two benefits. Firstly, if I want to pass this name in as a parameter, it makes sure that that flows through. But secondly, this creates a dependency between the storage account and the resource group. So it won't try and create the storage account before the resource group is created. You can have dependencies in ARM templates, but you have to manually define those. And the same thing, I'm grabbing the location from the resource group as well. The rest of them are the same, and then all I've done here, I've added an output, which we didn't have in the ARM template, but we could have. But this just outputs a value at the end of running the template, which in this case is the connection string to the storage account. And this will be output to the command line, but I could also then use that to pass that into something else that's going to be triggered by this template. I could have that, if I ran this as a pipeline in Azure DevOps, I could have that picked up as a pipeline variable and passed on to the next stage, and so on. So if we run the Terraform, as I mentioned, there are a couple of different options. So the first thing we can actually do is we can run Terraform plan. This is what I talked about, where we'll go off and it will look at what's in its state file, and it will tell me what it's going to do. Now, at the minute, I've got a completely empty state file. So what it should come back and tell me is that it needs to add these resources, which is what it's done here. So there's quite a lot of text here, but basically what it's telling me with the green plus is it needs to create a resource group, and it needs to create the actual storage account, and it shows me all the properties that it's going to set on that storage account. And some of these it knows already because I passed them in. So like this kind and replication type, it knows because I passed those in as values. Whereas some of them, like the access key, which that's not a good example, but like the blob endpoint, it doesn't know currently because it hasn't created the resource. So it's going to tell me that after I apply it. So it will show me what it's going to do. And I can see all the properties of that if I want to. Now I'm happy with that, I can run Terraform apply. And that will actually create the resources. The first thing it's going to do, it will actually run plan again for me and get me to confirm that what I asked it to do is what I'm being shown. So I can type in here and say, yes, that is what I expected. And that will go and create the resource for me. So give that a minute to create. It shouldn't take very long. What I want to do here is now I'm going to go and change this to LRS rather than GRS. And so once this is finished, we'll rerun the plan so you can see what it looks like. Now I've got existing resources, but I want to change them. There you go, so that's created. So if we run Terraform plan again, and this time the state file's got the information in it of the things we've already created. So what it should come back and say is that it needs to edit the existing account. Now, what I think it will say actually is it needs to delete the existing account, storage account, and recreate it, possibly. Oh no, it is going to change it. Okay, so you can see here it needs to change the storage account, and you can see what it's actually going to do. This is the change it's going to make. So it's going to change it from GRS to LRS. That's the only change. So you can see it's got this graphical representation of what a change. There'd also be a red minus if it was going to delete something. So we're not going to do that, but I want to clean up now. So I can just run Terraform destroy. And again, it's going to ask me to confirm that what it's telling me it's going to destroy is what I want. And then that will go ahead and it will delete those resources from Azure for me. There you go. See the red minus is going to delete all these things. Yes, I do wanted to do that. Okay, so that's what it looks like in Terraform. The second tool I mentioned is one called Pulumi. Now, Pulumi is an interesting one because Pulumi basically allows you to write infrastructure as code in actual code. So instead of having to write JSON or having to write the HashiCorp configuration language, Pulumi allows you to write with actual programming languages. So it supports, I think, 4 or 5. So it's .NET languages, JavaScript or TypeScript, Go, Python. I think that's it. But it supports using those languages. And this can actually be a pretty big benefit if you're trying to write complex templates. So what we've seen so far is fairly simple. We're just declaring one resource. But it won't be uncommon when you're writing ARM templates that you want to do more complex things like have loops. You want to deploy X number of resources based on an input somebody passes in, or maybe somebody passes in an array of resources. You want to do conditions, so if statements and those sort of things. Both ARM templates and Terraform have constructs that allow you to do that. But because they're not really a complete programming language, they're not the nicest things in the world to work with. Particularly if you've ever tried working with a for loop in Terraform, it is quite painful. Whereas if you use Pulumi, you can use actual programming constructs. So I can just write a for loop in C#. This is C# we're using here. I could just write a for loop, an if statement. I can use all sorts of programming paradigms. When I want to, we talked earlier about modularity and creating modules. Both Terraform and ARM templates have a module process where you can create code files that are modular, but you've got to find a way to distribute those by putting them in a storage account or in a Git repo or those sort of things. Whereas with Pulumi, again, because it's just code, I can bundle those in a NuGet package and distribute that to my team. So we actually use this now in my day job, mainly because we are in a role where we're trying to get the development teams to take a lot of responsibility for writing the actual deployment. So in a more DevOps world, we want them to take responsibility for that. They are C# developers. They don't really want to go and learn another language or have to pick up, HCL or JSON, those sort of things. And they're used to writing in C#. So giving them this allows them to write their infrastructure as code in a way they're familiar with. And it so far seems to be working pretty nicely. It's obviously if you're coming from a world where you're more of an on the ops side and you're not a developer, then this might not be appealing at all, and you'd prefer the HashiCorp that language, which is sort of simpler and more declarative. But these are options. It's worth considering. So this is the same template as we use the other ones to deploy a storage account, and you can see it's not dissimilar to the way Terraform works in that it actually has the resource group and the storage account object, and actually under the hood This is using the slightly older, so the older version of the Azure provider, which is actually based on top of the Terraform one, which is quite interesting. The newer version isn't, but this is using the older one because the new one's not GA yet. But very similar sort of thing. We're deploying a resource group, and we're deploying a storage account, and we're passing in the properties that we need for that. And then we've got an output again, which has the primary connection string. So very similar way of doing it, but using C# rather than the built-in language, the language of the HashiCorp stuff. And if we have a look at that, we can do similar sort of things because again, it's got this state file. So we can do Pulumi preview, which is the same as Terraform plan, and that will show us what it's doing. I mentioned before that one of the benefits of Pulumi is you can actually encrypt the data in the state file. So this is asking me for a key. You can have this automated through Key Vault and have it pull the key automatically. It's just a demo. I haven't actually set a key. Because this is actual code, what it's doing now is it's running a .NET build, so it's actually compiling that code, and then it's going to run it. And once it runs, it's very similar to Terraform in terms of it will show us the plan of what it wants to do, and we can have a look at it. So you can see there, same sort of thing. It's going to create a storage account and it's going to create a resource group. And we can use Pulumi up, which is the same as Terraform apply, to actually run that. And again, it will give us the details. You see there, it gave us a very high level view. If you remember from the Terraform one, we had loads of details about what it was going to do. This is giving us a high level view. But when we run the apply here, or the up, sorry, again, it's doing a plan first, and actually we will have the option to have a look at some more detail. So this is what we saw before, the same amount. But if I go into details, I can actually see all the individual details for the resources then as well. Run that, and that's going to deploy the resources to Azure for us as well. So very similar concepts in terms of the plan, apply, destroy. You can do the same sort of things, but with a different language option and a different way of interacting with things. And I'll leave that running. So the question then comes, okay, well, what tooling should you use? And it's really going to come down to your choices. We've listed the most common ones here. There are a few others as well. There's a couple that are, I mentioned before, there is Bicep, which is a tool from Microsoft that sits on top of ARM templates. I haven't mentioned that here, but that is a sort of abstraction on ARM templates. There's also a third-party one that created to do a similar sort of thing called Farmer, which could also be something that you might be interested in. But I've just summarized sort of the ones we talked about today. And so the choice is, one of the things that's going to drive you first in this area is whether you want to look at multi-cloud or not. If you need to be able to deploy to multiple different cloud providers or non-cloud things, then you need to look at using one of the third-party ones, Terraform or Pulumi being the most common. And it might not just be multi-cloud. I mentioned this. So one of the use cases we had for this was the fact that we want to deploy AKS clusters using into Azure, and we could use ARM templates for that. But once we deploy the Kubernetes cluster, we also then want to deploy some resources onto it. So we want to deploy some common tools that people use, like Nginx and Cert Manager and so on, onto that cluster, so it's ready to use for our developers. ARM templates can't do that; they can't deploy actual Kubernetes resources. Whereas Terraform and Pulumi can do both those things. So even if you're just in Azure, but you think you might want to actually be able to do that sort of thing, then one of those tools might be useful. Language is going to be a factor. Each of them have their own different language choices. So it depends, are you happy writing JSON or the HashiCorp DSL? Would you prefer to write real code? You can do that in Pulumi. CloudFormation, if you're on the AWS side as well, has an option for writing TypeScript and JavaScript and so on, specifically for AWS resources. So that could be a deciding factor in how you want, what language you want to use. Whether state is something you're interested in and getting the benefits of that, or whether you don't really care and you don't want to have to deal with the state file, so you'd rather just have the more stateless options. Open source, obviously, that could be a concern. Support is something that would factor into this, I suspect. If you're already getting support from your cloud provider, do you want to continue doing that, or are you happy working with a third party and either getting community support or paying for their support contract? And then finally, they're looking at some additional features that you can use with those. So policy is a big one that comes across all these services. So obviously AWS and Azure have a policy feature which you can create as your policy statements with ARM templates. They apply at the cloud level, whereas if you're using something like Terraform or Pulumi, they have a policy tool themselves as well, which can actually be applied at the time you start deploying the resources on the Terraform or Pulumi side, but you've got to pay for that. That's one of their enterprise features. So very high level, just comparison chart there. Hopefully to give you some idea of which tools do what. So I mentioned this earlier, but infrastructure as code is just code. So we can do things that we would generally do with code. And if you're a developer, a lot of these ideas will seem fairly familiar. Whereas if you're coming to this from the IT ops side of things, it might seem a bit alien. Even if you've got over the fact that you're writing the code, but somebody comes along and says, okay, well, now we need to write some unit tests for your infrastructure. That can seem a bit of an alien concept. But you can do that. You can write testing for your templates. You can build CI/CD pipelines that actually deploy your resources. You can version control your resources using Git and so on. And you can use IDEs that you would use for developing. So I was using Visual Studio there for the Pulumi stuff. You can use those to help you write the code. So if we just have a look at some of those areas. So the first one I wanted to talk about was testing. And we've got an ARM template here. I think it's the same ARM template. It's a more complicated ARM template we're using here. But we're going to have a look at some tests so that we can actually, before we run this template and deploy some resources, we want to run our test suite against it, which should hopefully detect issues before we actually deploy resources. Because as you probably know, if you want to deploy something in Azure, it can take a while. And if you're deploying a load of VMs and so on, it can take quite a long while, particularly if there's dependencies and you have to do it in serial. So if you can spot an issue with your template before you get to the very, you deploy it and the error is always in the very last thing you want to deploy and you waited an hour and a half for it to break. If you can detect this early, then this will save you a lot of time and potentially money. So there's two test suites I want to look at. First up is one that's actually produced by Microsoft and doesn't involve actually writing any code yourself, which is called the ARM Template Test Toolkit, or ARM TTK. So this is something that Microsoft have written. And what you can do is you can import that module. It's a PowerShell module. You can import that, and then you can run test template, I think it is, yeah, and give it the name of a template or a folder of templates if you want to test multiples, and run that. And what this does is it runs tests against your template for common best practice issues you might have in your ARM template. So things like, your admin user name should not be a literal, your API version should be recent. So I failed this test. So I've got some older API versions in this file. So I failed that one. The scheme is correct. The location shouldn't be hard coded. So lots of different things. So these are best practices that Microsoft have, in fact, the ARM team have created tests for that they think you should be checking your ARM template against. So you can run these just by installing the PowerShell module and then running that test like I did there. They're very simple to do, and they can give you a sort of first level of testing to see if your ARM templates are following best practice. That's a very simple thing to implement. The next stage, though, is writing your own tests. And so what we've got here is a file for testing the ARM template, and it's written using a tool called Pester. Now, I've not got time today to go into great detail on Pester tests and writing these tests, but Pester is a PowerShell framework for testing things. Originally, it was written for testing PowerShell scripts, but you can use it for testing pretty much anything, and we're using it for testing this ARM template. And so I've got some tests here, and Pester has this syntax for things. So describe, context, it. These are all Pester keywords. The describe and context basically just allow me to create buckets of tests so I can group my tests together. But the interesting bit is these it statements. So it uses this sort of test-driven development syntax of it, name of the test, and then the actual test I want to run. So I'm doing a few simple tests here. First up, I'm checking that the actual template exists. So the ARM template should exist. The same for the parameters file and for a metadata file. Just checking that file exists. Very simple. Then I'm checking the actual ARM template itself to see if it contains the expected properties. So you saw before that an ARM template has these different sections: schema, content version, parameters, variables, and so on. So I'm checking that they exist in this template. And I'm doing, yeah, there's actually two tests wrapped in one here. So I'm checking the content, but I also, what I'm doing here is running this convert from JSON command here. So what that does, it attempts to convert the actual file into a JSON variable. And the reason I do that is because if there's a syntax error in my JSON, that will fail and it will throw an error. And so I will be able to know that, I missed a comma or a bracket or something. So that will fail if I've messed up my my JSON. Then the last test here is a bit more specific. I'm checking the template to make sure that it is actually creating the resources that I expect you to. And this is a bit of a change of thinking, in that when you're writing templates or writing code in general, you're trying to make it pretty generic. You want to be able to have as many people use it as possible and reuse it if they can. Whereas when you write tests, you are going to be a lot more specific. So I'm checking that my template specifically has these type of resources created in it. And that's obviously going to be down to what's in my template. If you were writing your own template, you'd need to change that. It's a different mindset there. But I'm checking that. And then lastly, what I'm doing here is I'm running a command. So you saw before we use the create AZ resource group deployment command to actually deploy the resource. There's another command here which is called test AZ resource group deployment. And what that does, if you run that, it runs the same pre-flight checks that would normally happen when you run the create command, but it doesn't actually run the template. So this allows you to just run it against the ARM fabric and see whether there's any errors that the ARM would throw up before you run it. So what I do is I run that test, I collect the output, and I check that it should be null. If there's no errors, it should be null. And so if there's something in it, I failed those tests, and so that will report in my test. The additional thing in here is that this command requires you to run it against a resource group. Even though you're not actually creating any resources, the resource group still needs to exist, which is a bit odd. But we're dealing with that by having this before all command. So this runs before we run any of our tests and creates the resource group. And then at the very end, we've got an after all command that will delete the group. So it's only there for the period of the test. So we can run that test now. Command. So again, it's just a PowerShell script. I'm just going to run that, and that will run our test for us. And so you can see it's found those files. It hasn't got a metadata file. I left that off intentionally, so you can see what a failure looks like. And it's run the actual validation against the ARM fabric now as well. But you can see it hasn't finished. It's taking a little while because now it's got to go and delete the resource group, which can take 30 seconds or so. So that's what that's doing. Now this is a very simple set of tests. You can make these as complicated as you want. I've got another example here where I'm actually testing to see that what I expected to be deployed has been deployed and it's configured the right way. So this test is something I would run after I do my deployment because I can't test my resources until they exist. But this goes and checks things like, is my virtual network there? Does it have the right IP ranges? I'm checking the virtual machines there and it's the right size and it's in the right region. I think I've got some other tests in a different file where I'm checking, has it got these extensions installed? You can really be as thorough on these tests as you want to be, because you can write them to test pretty much anything that you can write some PowerShell to check. So you can be as detailed as you want in those. Once you've done that, you can also then go a step further, and you can start writing pipelines for your template. So this is an Azure DevOps pipeline that I've got, and it's pretty simple. But what it does is whenever I check in a change to a particular set of templates, it runs a test. It runs that first test we looked at, which runs the pre-deployment infrastructure tests to see if there's anything wrong with them. If that passes, Then it will go and actually run my ARM template to deploy the infrastructure it's supposed to create. Then I run my infrastructure testing tests to check whether or not everything's as expected, and then it publishes the test result. Now, if this failed, if this first one failed, the build would stop at this point. It would still run the publish test because I want my test results, but it wouldn't run anything else. And similarly, if the test infrastructure fails, it will run the test results, and it will run this next step here, which is to actually delete the infrastructure. I don't want my test infrastructure hanging around, but then it will fail. Where if it's passed, it will then move on to the next step, which is to actually zip up my template files and copy them to a storage account, which is where people who are then going to use my template files will retrieve them from. So this basically gives me a pipeline to take any changes I've made to my templates, push them into Git, trigger a build, run my tests, and then push those into a storage account for me automatically. And that will all happen. If there's no errors, that will all happen automatically. If there's an issue, test will fail, I'll get an email saying the build has failed. I can go and rectify that, look at the test results, and so on. And then I can fix that and do it again. So I could fully automate the actual publishing of my templates, but you could also then build a pipeline that actually deploys these templates to your actual production environment if you wanted to, and again have similar checks in if you wanted. You could build pipelines to do whatever you wanted, really. Okay, so just wrapping up. If you're going to or if you're interested in starting to look at the infrastructure as code, then the easiest way to get started is to try it out. So have an idea roughly of what tool you want to use. Do you just don't want to start with ARM templates? Do you want to start with Terraform or Pulumi? Pick a tool. You can always change it later, but it's good to get started somewhere. And then just start trying to do it. That's the best way to learn, is to actually try this out. Start with a small unit of work like I did there, the storage account or something simple, so you can get the hang of how it actually all works. And then when you're ready, you can then start actually writing code to deploy your more complicated infrastructure. You will find you need to iterate it over time. You will find you spend an afternoon getting over this error after error, because each time you try and change something, it generates a new error. That is going to be a part of the learning process. But hopefully once you've done it a few times, you will get past that point. Don't do it in production to start with. It might be obvious, but do it in a test environment, try out these things, and then when you're ready, move into production. Keep your templates focused, keep them to small units of work, or as a common phrase there is lower the blast area. So what we might be tempting is to create a template that deploys your whole application suite in one go, deploys all the resources, which you can do, it will work. But what happens then if you want to make a small change to that infrastructure? You then have to run the whole template again. There's potential you might inadvertently make a change that impacts a different piece of infrastructure you weren't doing. And so one of the common design patterns here is to try and create templates that are sort of a single unit of work or a set of resources that have a similar life cycle, and then have set multiple templates. You can always have a template calling another template, or you can have a pipeline in your DevOps tool or whatever that will call the ones after another. But try and avoid making massive templates that do everything. Put your code in version control. I would recommend that as to anyone who's getting started with this is start your sort of DevOps and your development journey by putting things in version control. Even if you don't do testing or pipelines or anything like that, put it in version control. You at least have a store that's keeping your files. You've got them backed up, you've got versioning and so on. And then if you want to, once you've got the hang of writing the templates and you can deploy the resources, you can start looking at doing CI/CD and doing pipelines and testing and so on. That is it. Say all the details there. I'll put the slides and the demos online on GitHub. Feel free to send me a message on Twitter or the website if you have any other questions. But I think we've got a little bit of time for questions. So if there's anything you want to ask, just let me know. I see there's a couple in there already. So Nilesh, you asking, is it possible to delete selective resources? Yes, it is, depending on the tool. So obviously, if you're using ARM templates, you don't really have a programmatic way to do that. You'd go in and delete the resources in a portal or PowerShell or whatever. For Terraform or Pulumi, if you run Terraform destroy, for example, it will delete everything that's in your template. There is a flag you can add, and I've forgotten the actual name of the flag, but there is a flag now where you can actually give it specific resources that you want to delete or destroy, and nothing else. If you look at the documentation, it's on there, so you can give it specific resources you want. It's not the nicest thing in the world because you have to give it the Terraform resource ID, which you might not be obvious, but yes, you can do that. And then Mohammed, you ask, for installing Pesta, do we install any plugin or test written directly in PowerShell? Yeah, so if you want to use Pesta, you need to install the Pesta module, which is just a PowerShell module, but that's it. You will find that Pesta is actually already installed in Windows, but it's a very old version of Pesta. I think it's Pesta 3. You will want to update that to Pesta 5 to make sure you've got the most recent version. But as long as you've got that module installed, then you can write those tests using PowerShell, and that's all you need.
Okay, sure. Thanks. So, hi everyone. If you have any questions, so you can unmute yourself and can directly ask as well.
No questions? Okay.
Yeah. Thanks, Sam. It was a really nice session. Maybe I will also take a look in that to start. Yeah.
Yeah.
Thank you so much for
today. No problems. No problems. Hey, if anyone has any questions later, just send me a tweet and I'll be happy to answer.
Okay. Thank you. Thanks everyone for joining the session today.
you.